So an introduction of myself. My name is Ben Lydon, and I'm a project engineer here at Hydro International. I got my degree from the University of Maine, and I've been with Hydro for just about 6 years. Great place to work, love working here, and I do love what we do. So, it makes it enjoyable to come to work every day. At the moment, I typically work on projects in Texas, Virginia, and Western Canada, but I've had a few different roles in Hydro International that give me, a pretty good understanding of the industry and the nuances inside our industry, our stormwater industry. From coast to coast, I've worked in Canada, I've worked in the U.S., Mexico, Brazil, and I do from time to time and on occasion work on industrial projects. So I have a pretty good understanding as a whole. Again, there is my contact information. Feel free to email me. And again, if there are any subjects you want to hear a presentation on, send that to me and I'll make sure we address them. So an overview of today. Today's focus will be on sediment, what it is, how it's defined, why it's a problem, and how it relates to manufactured treatment systems. All manufactured treatment systems, just not our own. But a secondary topic I'm going to discuss will be the standards that surround sediment TSS. We'll take a deep dive into a few of those standards that are out there and that we typically see. And then lastly, I'll show you why understanding all of this is important to a company like Hydro International and what that information means to us. There will be a poll halfway through, a live poll that I'm going to ask a question and it will prompt you all to answer. We'll review those results. But then again, at the end of this presentation here today, there will be a survey and I encourage all of you to fill out that survey. Along with the questions, there will be an Amazon gift card given to someone that completes and submits that survey. And like I said, we appreciate all feedback here at Hydro International because we do love this webinar series. Before we start talking about sediment, I do want to tell you a little bit about Hydro International. I'm sure many of you are familiar with our company, but there may be some new. So I want to touch on this as well. I say this often, we're a small company that punches above our weight class. Let me tell you why. I'll show you who we are as a company, but when I'm talking about America's Stormwater, it's our Stormwater division, and we are a small company of probably 70 people that make a big difference and a big impact. How we do that is through our many capabilities. You'll see listed above. But in general, we deal in water treatment. We are related and tied to storage very often, but we don't sell storage systems directly. We don't sell pipe. We sell treatment systems, whether they be wastewater or stormwater systems. And as far as the list, you can read down through our capabilities here. What's new and exciting to me is this monitoring piece. You see it two up from the bottom. So for years, we've been installing grit separators that focus on hydrocarbons, oils, and everything. And I think probably 40 years ago now was our first install actually in Ontario, Canada. But what we're doing now, bringing into the current century, where everything's smartphone, smart data. If it's not on your phone, you don't want to use it. We're putting these monitoring devices in our units that can tell you how much flow is going through the unit, how much sediment is in the unit. If that sump is at capacity, for our filters, they tell us about our filter media. They can tell us whether that filter media is new or if it needs to be replaced. So we're not just installing something in the ground now. We're giving you a live 24-hour feed as far as is that device working, how well is it working, and does it need to be maintained? So you can imagine in the future, there won't be as many times you're sending maintenance trucks out to a site to see a manhole that's empty. You'll be able to decide if you need a maintenance crew there before you send anyone out there, as well as is that device you put in the ground working? If it's empty always, is it cleaning what it's supposed to? So I love to touch on this data analysis that comes with the hydrometry and the monitoring. It's not available everywhere yet, so please reach out to me and we'll see if we have it in your area. We've been doing a lot of pilot testings around the country, and it's just now really being commercialized. But please, if you want any more information on the hydrometry, these data logger devices, please reach out to me. They do. You'll see we have industrial stormwater listed there. That is where we're seeing these devices installed, because the difference with industrial sites is it's not enough to do the legwork before it goes in the ground. Once it goes in the ground, that's when the real fun starts. We thought it was going to remove X, Y, and Z, but is it? And are you conforming to your TMDLs of your local area? So it all comes together. So I mentioned earlier, I am here located in Portland, Maine. Oddly enough, our wastewater division is in Portland, Oregon, and we even do have an office in a Portland out in the UK. But our genesis was out of Clevedon, in the United Kingdom. You'll see the dot there. But you may be thinking, we are an international company, but why is that important to you? Being an international company allows us to stay up to date on practices from all around the world. For instance, our UK office deals mostly with flood control, where in the States we deal more in water quality than water quantity. But we were recently approached by a city in Brazil that had a huge flooding problem. So we may not have been the experts, but we knew who the experts were. We teamed up with our Clevedon office to bring the city a solution that worked for them. So we're able to pull from practices from Australia, New Zealand, wherever they may be. If they're new, if they're working, we can incorporate them into what we do here in the United States. So having that global vision really does help us stay on top as an industry leader. In our stormwater expertise, I've touched on some of this, but the biggest part that I'd like you guys to know, or all of you in attendance, is that we have one of the largest manufacturer-owned laboratories in the country, and it's actually right here in Portland, Maine, attached to our offices. We recently put in over $1 million to upgrade, add more space, add more equipment, because when it comes to stormwater in these devices, it's testing, testing, and testing. This laboratory allows us to be quicker, it allows us to be innovative, and it allows us to be in touch with the changing regs. Nothing in this industry is stagnant, and neither are we. A good example is as trash capture is becoming more predominant, led on the West Coast in California. There is now a requirement for a 5mm screen effectively to capture cigarettes in stormwater. And our Downstream Defender, that's one of our oldest product lines, did not meet that 5mm screen requirement. So in our own laboratory, we were able to develop a screen to be placed inside of our Downstream Defender to meet that new 100% trash capture requirement. So this just shows how we don't go out and find new products. We, if possible, will improve what we already have at hand to fit the changing regulations. Now, we can't always test here in Maine with so much going on. So as far as collaborating with colleges, schools, we love to do that. Currently, we're working with a school in Florida on vector control, because in Maine, when it's the middle of winter, there aren't many mosquitoes out there. So we like to pair with lots of people when we can't do the testing, or it's not appropriate. Maybe it's a long-term study or something like that that's better fit for a university. And then as far as certifications, our results are verified, certified, accepted by many third parties. And these regulatory agencies have developed standards and test protocols that we specialize in understanding and working through to make sure our devices not only work but are approved in the areas for use, so that we can help provide a solution all over. Now for the good stuff. So before we get into sediment, I do want to just mention this thing, the learning paradox. And another fun fact about me is when I first went to college, I was a Greek mythology major before switching into engineering. And if you'd ever like to hear more about that, that's a whole nother hour. But I have this quote here, and I'm sorry if I have the place wrong, but I believe this was a quote from Einstein saying, "The more I learn, the more I realize how much I don't know." And I have Socrates and Plato and Aristotle up there. And there's famous quotes from Socrates, I know nothing. And from Aristotle, the more you know, the more you know you don't know. And that's the overall theme to this presentation today. I felt when I started 5 years ago here at Hydro International, I knew about sediment and I knew about 80% removal. But the longer I've been here, it's sort of peeling back the onion in the different layers. So you start, the top layers is 80% removal, but then you get into sediment. Then you get into particle size distributions. And the more you learn about it, the more you know how much was out there that you hadn't even touched the surface on. So this will be a reoccurring theme in the presentation. And it's okay to not know everything. It means you're learning. So pollutants in stormwater. The goal of stormwater management is really to limit the disruption of the natural waterways. It's the same idea behind conservation. And by disruption, what I mean is adding volume or adding pollution to those natural waterways. And today we're obviously going to focus on pollution. Above I've shown sediment, trash, oil, and nutrients. So you can see the effects of these different types of pollutions in the pictures. But again, we are trying to reduce as much as possible all of these through proper management measures. According to the US EPA, sediment is the biggest problem. Sediment is the concern when it comes to impaired waterways. Through testing, we have found that when you remove sediment, you're actually doing much more than that. Sediment-bound metals and other pollutants that adhere to that sediment will also be removed. So removing sediment is a good way to lower the amount of pollution in total. And to be honest, if these devices also can capture sediment, the odds are they can capture trash. So by focusing on sediment, you're actually taking a large step towards the greater problem. So let's look at sediment and solids. Hydro offers several products depending on your site-specific requirements. Below we have a table showing dissolved solids on the left, all the way up to trash on the right. And there is a corresponding relationship between the particle size that you're trying to remove and the flow at which you typically obtain that removal. Smaller particles are in general treated at smaller flow rates. Well, if you're looking to remove trash, shown on the right, we have a hydro dry screen, which is much like a trash screen. That can remove trash up to 60 CFS and 60-inch pipe, where when we're down the lower side of the scale with our upflow filter, we're typically treating 0.1 CFS to 2 CFS usually with our filters. Our suite of solutions go across the board, but I'd like to touch upon our portfolio, including screening. That's the trash screen I talked about. The hydrodynamic separation, which will be a focus in today. We have media filtration and membrane filtration, which go to our upflow filter. And then chemical applications. And this is really in the industrial application that we don't even want to get into, because this could be using chemicals or flocculants, and all of a sudden everything we talk about particle size and particle size distribution goes out the window there. So that's an industrial process, not typical of your usual stormwater applications. And most of what we talk about, and especially today, you'll see here this range of dissolved solids to trash makes up total solids. But on the next slide, we're gonna peel back that onion and go from total solids to TSS, where we're gonna really look at 1 micron to 1,000 micron particles. Our products that we use to treat this 1 to 1,000 micron will be the upflow filter shown on the left, or one of our hydrodynamic separators. The two are shown there, the Downstream Defender in the middle and the First Defense on the right. The major difference between the Downstream Defender and the First Defense, they both work using the same idea of Vortex, induced vortex for removals, but the major difference between the two is one has an internal bypass where the other is a full flow treatment device. So that's when peak flows come into play. And if you need any more information on that, again, send me an email and I'll be happy to address it. These separators, the Downstream Defender and the First Defense, typically can provide treatment of that TSS from 0 to 25 CFS. So that's what we're talking about. So I've said TSS maybe 5 times now. Let's define it. We had total solids. Now we're going to TSS, and this little classification chart on the right sort of gives a visual to what I'm talking about. So we hear the term TSS a lot, total suspended solids. That is the breakdown of total solids, where we have the suspended solids and the filterable solids. Anything filterable solids not highlighted in blue here, you will definitely need a filter for. The suspended solids are what we're able to remove with a hydrodynamic separator, basically saying that gravity will allow them to fall into the sump to achieve that goal of cleaning the water before it moves downstream. Now, I would think that almost everybody here has heard the term 80% TSS. It is the industry standard. But what we're going to touch upon today is when is a standard not so standard. So this standard has been developed but passed down to state, county, and city levels to interpret what it means to them. Now, you're talking to different engineers, different regulators, different people in the industry. Some will say this is a good thing. Some will say it's bad. It's both. Like anything, too much or too little can be a bad thing. In my opinion, it's finding a balance between the two. And although leaving definitions loose and left up to interpretation can add some confusion, it also gives you an advantage because it brings it to the state, the cities, or the counties to mold their practices to match their local pollution specific to their area. So it lets you tailor-made that BMP manual or design manual that you have to really match the pollutants of your concern. So you can imagine one standard would be too broad. And let's look at what some of those standards are. So here, Massachusetts, you'll see in their design manual this requirement for 80% TSS removal. New Jersey, you'll see it again. City of Chattanooga, remove 80% TSS. California. But now we're going to peel back another layer. 80% of what? And to understand all this, we do have to define particle size. And what is a micron? We keep saying micron. Hearing the word micron, whether it's 1 micron or 50 micron, you may be asking yourself, how big is that really? What does that mean? A separator can remove down to 50 micron. Well, what is that? this table on the right shows a micron scale for sand, and you can look. So our separators may be challenged by silt, but everything else shown there, they should have no problem removing. And then this particle is then passed along into a particle size distribution. And a particle size distribution, by definition, is the relative amount by mass of particles present in a sample according to size. So in future slides, we're going to look at a couple particle size distribution curves for a few sites. So making sure we understand the relationship between everything will be key. If you do want to learn more about how to interpret particle size distribution curve, we have talked about it in past webinars, and that link will be available to you at the end of this presentation. Okay, so the USGS, the United States Geological Survey, has done some of this work for us. They had an initiative to characterize the particle size distribution of urban stormwater runoff, and partnered with NERP study areas, which is the National Urban Runoff Program. They took different sites looking at parking lots, streets, rooftops, and mixed-use sites, and they took samples that we're going to review. And it's worth knowing that each one of these, let's just go to it. So for the parking lot, each one of these lines is a different sample that they collected at this one site. And so you can see it fluctuates, it varies depending when they sampled it. Could be different seasons, but basically each gray line is an individual sample where the mean has been bolded in the middle. Looking at this graph, we can see that 85% of sediment fell between the 2 micron and 500 micron range. Now, going back to what we hear about 80% TSS removal, you need to know when looking at this and comparing it to 80% TSS removal, are you looking at 80% TSS removal of all the sediment, or the sediment that's bound by a certain limit? Are we being asked to remove 80% of TSS between 2 micron and 500 micron, 1 micron and 1,000 micron? And if you do set limits to that, are you actually getting 80% of the total or not? Now, looking at these graphs, we will notice, for the most part, this is a collector street. They are all fairly linear. Again, here with the feeder street. And when I say it's a linear, it means that all of these sites are showing a good mix of particle size. So the particle, it's not all sand, it's not all fines, it's not all, big rocks. It's a mix, which is great, because then we're not designing a separator to look at one specific particle. We're looking to treat the site. Here again with mixed use. And so some results of this study. They could see different D50, which is the median particle size. The D50 is the median diameter of those particles. So you can see how the different sites had different results. But so what do we do with this data? What should we do with this data? Should there be a different set of removal requirements for collector streets as feeder streets, because one is 70 micron and one has 200? I would say no. At the moment, there's not. That would take way too long in your design process. You're working on your project, and if you are doing a DOT job or any project in general, we cannot get that specific. So what we end up doing is making some standards or some generalizations, some assumptions to streamline this process. And those assumptions, those generalizations, we can make with confidence because of studies like this. Okay, so here's the first poll. You'll see some curves here. There are 4 of them, and you'll see the different regulatory agencies that they correlate to. Some of them are linear and fairly mixed, like you'll see in orange, the New Jersey curve. So they're looking at a wide range of particles, where if you look at the OK110 or the down to 50, they're more uniform. They're looking at a specific particle size. So some are mixed, better than others. But I'm going to ask a question here and take a minute to look at the colors. And you see I have A, B, C, D, and E. Which of these curves best illustrates the stormwater you see in your area? Okay. Apologize, we're having a little hiccup here. Okay. There we go. The poll should now be open. Give everyone a couple minutes to get their responses in. All right, so I'll share the responses with you now. Pretty even split between red line, green line, and the light blue line, which looks like we're looking at the ETV, which is Canadian and New Jersey particle size distribution, the fine sediment particle size distribution, and then our down to 50 micron. Being in the industry and working here at Hydro International, I'm not totally surprised by that. The down to 50 are probably more coastal areas looking at fine sediment, but for the majority of us, we know that our stormwater is a mix of small and large particles. But that wasn't my only reasoning for asking this question. Part of my goal today is to get everyone, and hopefully a few of you did, ask yourselves the question, well, stormwater in my area, that's too general. Are we talking about, in the industrial park? Or are we talking about out on the highway or at the golf course? These are the questions that we all need to ask ourselves. And I guess another question would be, keeping with that theme, do you think any of these curves would hold true for every single state or province that are out there? For the most part, probably not. And so that's why we have these industry standards. Regulatory agencies like those listed above have taken everything that I've mentioned today into account to make things easier for us, to make things happen quickly. And they keep an eye on everything as it changes and as we learn and know more. You'll notice, looking at the different names that are up here, they cover all parts of the country. You see some are from the Midwest, some are West Coast, East Coast. And like we said, that they take this information and they tailor it to what they actually see as far as pollution in their area. So now we understand sediment, we understand particle size, we understand all of this, and I'm going to bring up a new word now, performance. So performance is tying all of this to the manufacturer. All of these factors in the Venn diagram go into product performance. And to me, when I think of performance, I'm thinking of high flow through a small footprint. Anyone can treat 80% TSS. Anyone can treat 2 CFS. But in what diameter unit are they doing it? In a 3-foot, a 4-foot, a 5-foot manhole? And so you cannot talk about performance without talking about flow rate and diameter. And And to compare these different units, you'll need to look at everything in combination, understanding that they are removing 80% of what PSD at what flow rate and what diameter. When you can do that, you can accurately judge the performance of different devices side by side. Now, knowing this and knowing what we're going to target is how Hydro International stays a leader in the industry. And we're going to talk about particles and settling and now how to capture them to achieve that high level of performance. I have here a little chart showing different particle sizes along with the typical time it takes them to settle. And all you need to take away from this, which you already know, is the big stuff is easy to remove, while the smaller stuff can be a little bit of a challenge and it takes a little bit longer to do so. But luckily for you, Hydro is here. We know vortex separation, and that is the key to separating these 50 micron or larger particles. It's in our logo. It's what we've done from day one, and I'm going to show you a little bit of what that vortex looks like in the next slide. So everything goes back to Stokes' law, and I did believe I had a slide in here, which I'm not sure if it'll pop up later, but we'll find out. But Stokes' law takes into account settling time and residence time. Understanding the relationships and principles is what keeps all of this together and makes us very effective in our laboratory out back. So we know in order to remove a particle, there is a settling time associated with that particle that is tied to its diameter. And to remove it, our residence time, or time that that particle spends in our system, has to be greater than the settling time required. So to be successful, we need to do two things. Increase the flow path, which therefore increases the residence time. And then we also need to smooth out that flow path, remove as much turbulence from it as possible to decrease the settling time required. And what I've shown here is a model of our Downstream Defender, which is our full flow capture device. And I'm going to show you a demonstration of the internals being made clear so that you'll see sediment coming into the treatment chamber and you'll watch it settle out. Now, sediment will come in from the right to the left. And what you'll see is we have submerged that inlet pipe and put it on tangent to reduce as much turbulence as possible. Again, decreasing the settling time. And then what our internals do in that internal connection to the outlet pipe is that increases the amount of time that water spends inside our system. So right there you can see our goal is for the 80% removal to happen right there in that system and as quick as possible in the smallest footprint as possible. This at 30-second mark, you saw it ramped up to a peak flow. So that first 30 seconds was the water quality flow, followed by the peak flow for the device. So what do you get after testing? All of our devices get tested at different flow rates with different particle sizes. What you're seeing here is our removal performance curves per the New Jersey NJDEP laboratory test protocol for our 4-foot diameter first defense unit. Now, the red line, the horizontal red line you'll see is at the 80% removal mark. So going back to the questions that you'll get, somebody could say, I need 80% TSS removal. And the first question to be asked might be, well, what flow rate? So say someone says at 2 CFS. Now I can demonstrate here at 2 CFS, if you're looking at the brown line that says 80% removal of 50 to 100 with a D50 of 75 micron, we're not quite there. So does that mean our 4-foot can't remove 80% TSS? No, it means it can't remove 80% TSS with a D50 of 75. So we can look at the next line. They can achieve it at 80%. But then we see another line that can achieve 80% removal at 4 CFS. So here you're starting to see a little bit of the gray area that you want to make sure manufacturers aren't using to their advantage when providing you a unit, because we know at the end of the day, when it comes to the contractors, they look at cost. Now, what I would like to take here is just 2 seconds to look at the grayed out dots at the bottom left of the chart. These are showing particles less than 50 micron. And you'll see here the removals are very low and at very low flow rates, further showing that basically, in order to get that 80% TSS removal of microns smaller than 50, you're going to want to go to a filter and not a hydrodynamic separator. So when you're sitting at home, most of you sitting at home now, trying to sift through this data, you're going to get something like this. Our 4-foot first defense is approved for removals at many different flow rates. We have New Jersey here. We have 110 micron down to 50 micron. D50 is 75 micron. F60, which is another sand blend. So you have all these numbers out there. Again, just further stating the need for these regulatory agencies, because what they do, such as New Jersey, I'm showing a list of NJDEP certified devices. They take all this information for you and they organize it by model size. So you have your diameter, and I've highlighted all the 4-foot diameter units on this chart. So again, they put it in, and that's why many places point to New Jersey to say they've already figured it out. Let's figure it out. Let's just adhere to their standards. But again, very important to know and understand when looking to compare some of these devices. The other thing you'll see on this chart is New Jersey has approved all of these devices at 50% TSS removal, but all day we've been talking about 80% TSS removal. So what that means is none of these devices are approved as standalone devices to achieve 80% TSS, meaning you need to use them in conjunction with some other treatment practice to get there. So wrapping up, what have we learned? All devices are approved at certain flow rates based on sediment loads and removals. Standards have been made by testing agencies to make apples-to-apples comparison of these devices, and understanding what questions to ask when comparing your different options is key to preventing issues like undersizing or not getting the intended removals you were hoping for. And I'll just add, there is sometimes a reason to remove larger particles and not the smaller ones. So you may be looking for a removal curve of 250 micron particle, because the more you remove, it all relates to maintenance. So there are times where you're not always trying to get down to 50 microns. Sometimes you want to stay away from 50 micron. So what is your role? Regulators point to a standard or develop one if there isn't one already. Depending where you are in the country, sometimes it only goes as far as 80% TSS without any PSDs specified in the manual. Engineers need to adhere to that standard, but it's also a good idea to make sure the site characteristics match closely to those of the testing protocol. Manufacturers then size and design to the engineer's request, with end users making sure that these devices are properly maintained so they don't just work the first year, they continue to work as intended year after year. And if you have any questions at all about your local standards, or maybe you're in one state designing a project in a different state and you need help, feel free to reach out to Hydro International. We stay up to date with all of this. And we're also very happy to provide guidance if needed. But we make it even easier than that. You don't have to call us. We talked about smartphones and apps and everything. So we now have design tools shown here. hydro-int.com/BMP sizing. We have a sizing tool for each one of our units to make this part of your process, this part of your design, as quick and as painless as possible. So what that design tool looks like is shown here. The sizing tool allows you to size by particle size, regulatory body, or you can use the manual selection tool to sort of play around with your options if you're not there yet. It does make recommendations as far as what system would be best for you based on flow rate and area. And you can use this tool at any stage in your design process. You're able to save, come back, edit, change any designs you have, and then there's even a button that you can click to submit it to our internal engineering department here if you'd like to have that design double checked before you put it on a set of plans. My last slide here is showing just a look of what that tool actually looks like. So this is me using the tool earlier today. And what I want to point out is if you look on that drop down that I've highlighted under regulatory agency, we have there the City of Fort Wayne, City of Indianapolis, Washington DOE. In Tennessee, we have Knoxville, City of Nashville, Johnson City, New Jersey DEP is there. So we've taken all these different regulatory agencies that approve devices at different flow rates, and we made it very simple in a drop down option available to you here through that design tool. That's very easy to use, and like I said, you can export drawings, summary, or submit for review. So I hope this helped. I hope I answered a lot of questions, but also got you thinking about some new ones that maybe you had or hadn't thought about before. And just like me, it's this continuing education piece, learning more about it. If you have any insights or anything on what I've said today, feel free. I'll share my contact information with you in a second. But again, we're going to put out a survey after this, directly following this webinar. If you fill out that survey, you will be put into a group of names that we will randomly select one to win this Amazon gift card. And then as far as PDH credits, those will be emailed out no later than tomorrow. So if you're looking for your PDH, you'll have that very quickly, and then we will announce the Amazon gift card winner later on. I hope I entertained you. I hope you had some fun. I hope you learned something. Again, the last chance there, my email is blydon@hydro-int.com. Please reach out. Looking forward to hearing from all of you. Thank you.